job today really is to write equivalent fractions. And when I say write equivalent fractions, what we're going to really look at doing the best thing we can do, we're going to write equivalent fractions. You might want to write this down using prime factorization. Okay. So the goal might be to write equivalent fractions, and somehow we're going to use that with prime factorization. The prime factorization is actually going to allow us to write fractions in simplest form today, and I'll show you what that means here in a second. But guys, quickly, equivalent fractions right here as vocab. Equivalent fractions say you have two fractions that represent the same number are called equivalent, right? So the example that I used was this. The fraction I was using was 1/2, right? We said that if I don't know, any basketball players in here? Okay then. If Fran McCaffrey's team was shooting 10 free throws, of which they'd probably make 0, especially when it was crunch time.
What was it, brunch time?
Crunch time.
Oh, okay.
I said if we make half of our free throws right here, and you shot 10 of them, you would expect to make what? 5 out of 10. Now you guys agree that you might think that these fractions are equivalent or be the same value, right? Okay. Now, mathematically speaking, guys, anytime you have a fraction right there, a numerator over a denominator, what operation is really considered between the 1 over 2? This is like saying take 1 and do what? Divide by 2. So if I did that right here, let's just punch that up and see what you get. 1 divided by 2. Numerically, what do you come up with as a decimal? 0.5, don't you?
Yeah.
Likewise then, if I hit my 5 divided by 10, again, what do you get as a decimal again? 0.5. So when you divide both of these fractions out, both of them come up with this decimal value of 0.5. Now are these values exactly the same right here?
Yes.
So what can I say about the fraction 1/2 as it's compared to 5 over 10? Are they equivalent or not equivalent? Okay, they are equivalent. Here's the deal. We're going to talk an awful lot about writing some equivalent fractions today, and here's what I really want you to get. Don't make this too tough on yourself. Guys, to go from a 1 to a 5, what would I have to multiply by? Okay, so to go from a 1 to a 5, we times by 5, right?
Yes.
Okay. What would you have to multiply by to go from a 2 to a 10? Is it 2 times 5 a 10? So basically, both of these numbers over here in the fraction 1/2, both of these values were multiplied by what?
5.
Did the same operation of both the numerator and the denominator to write an equivalent fraction, right? So I could have maybe done something like this. I could have said, you know what? Let's write an equivalent fraction for 1/2. Let's just pick an example. Could I take both of those numbers and multiply them by 19? I could. Let's just watch what I do here. If I say, you know what, I want to write an equivalent fraction of 1/2, I'm going to multiply this by, my choice was 19. What is 1 times 19, gang? However, if I multiply the top by 19, what do you think I'm going to have to do to the bottom to keep this fraction equivalent to what I'm trying to write?
Divided by 19.
Not divide by 19, do the same exact thing, times it by what? Can I times that by 19 also? What is 19 times 2? 38. All right. So what has to be true about the fraction 1/2 and 19 over 38? They're equal. They're equivalent. Okay. So when I start talking about today, write me an equivalent fraction, you got to understand you're going to do one thing to the top and the exact same thing to the bottom. What if I started with something like this? What if I had something like, oh, I don't know, 200 over 300. And I didn't want to make the values bigger. I want to make them smaller. What do you think?
Can't you knock off the zeros?
Can't you knock off the zeros? You bet you could. Okay. Knocking off the zeros, 2 zeros on the end represent like hundreds, right? She's saying this is the same as 2 over what, gang?
3.
Blair's question. 200 divided by what would make 2? 300 divided by what would make 3?
100.
Do we do the same thing to both the top and the bottom?
Yes.
Okay, 2/3 would be an equivalent fraction. Okay. You know what I like to do? I like to work zeros a lot. When they say right equivalent fractions, if I have like 3/4 right here and they say right equivalent fractions, I like to call one 30 and one 40. What did I multiply both by? 10. Okay, that's pretty easy, isn't it? Or I could just double both values. So let's start looking at what it is we're trying to do here, guys. Equivalent fractions, two fractions that are basically the same. In example 1, it says, write two equivalent fractions to 6/18. So I have this fraction 6/18. Okay? I can choose to reduce this. I can make the value 6 and 18 smaller by dividing, or I can choose to make the values larger by multiplying. Okay, let's do a smaller example first. Can you guys, first of all, I'll put smaller values in here. Can you guys think of a value that would divide into both 6 and 18? I really don't care which factor goes into 6 and 18 other than 1, but can you think of a number other than 1 that divides evenly into 6 and into 18? I heard it over here somewhere. Seth is saying, you know what, I think 6 divides into both of those. Do you guys agree? How many times does 6 go into 6? 1. Okay, so for the smaller value, let's divide both of them by 6. 6 into 6, how many times up here? You said? 1 time. How many times does 6 go into the 18? Okay, so we think 6/18 would be equivalent to 1/3. How do I know I'm right? Well, when I divide them out, shouldn't they be the same decimal? Check it out. 6 divided by 18. What do I get for a messy decimal up here?
A lot of numbers.
A lot of 3's, right? Do you remember that? If 1/3 is equivalent, what should I get when I divide that out? Same thing or something different? They're equivalent fractions. Should I get the same decimal or something different?
Same.
Do I?
Yeah.
Okay. 1/3 equivalent to 6/18 then? The answer is what? Okay. Good there?
Yeah.
All right. Let's try maybe a bigger value. Let's try and see well, values that are bigger. Okay, so what I'm saying is I want values, I want a numerator larger than 6 and a denominator larger than 18. Jenny, got an idea?
Oh, I had a question.
Yeah.
Do we need to write this stuff down, the words?
I would.
Okay, thank you.
Can you guys think of values that are bigger? Times by what? So he's saying take everything times 6. Do I have to use 6? Could I times everything by 2? Could I times everything by 3? Could I times everything by pi? Could I times everything by 22?
Sure.
I could, couldn't I? Okay, as long as you're picking the same value to do both. What value you want to work with?
2.
Let's times by 2. Let's times both values by 2. All right, so we're going to time the numerator and the denominator by 2's. Okay, so what's 6 times 2 going to get you guys? 12. What would the 18 times 2 get you? What would the 18 times a 2 get you? Oh, come on, guys. 18 times 2.
18 times 2 is 36.
Thank you, Jen.
You're welcome.
So another equivalent of fraction to 6/18 is 12 over what?
36.
Okay.
36, yeah.
All right, so equivalent fractions. This isn't not rocket science. You just basically need to either add or, multiply or divide by the same value to both the numerator and the denominator. So I'm going to throw some fractions up here, and yeah, on your own part. Let's go, how about 10 over 15? Let's go 1/4, and let's go 9 over 27, okay? On your own, what I'd like you guys to do is to come up with 2 equivalent fractions to the ones that are given. I don't care if they're larger or smaller. Just come up with 2. Now understand in this case right here, not all your answers will be the same, okay? Some people might multiply or divide by a different value. So see what you get there, okay?
Our calculators if you have.
You might want your calculator for this. I would suggest it.
Thank you. Yeah, but I have my brother's old calculator.
Blow the dust off of it?
What?
Did you blow the dust off of it yet?
Yes. A few scratches on it. But it's when we divide a number by number one, like the answer I
As long
got.
as you do the same thing to the top as you do to the bottom.
Sorry, Mr. Person, I was talking to Brandon. We just try to make an equivalent fraction.
Anyone.
Okay.
I don't care what it is. If it's bigger, if it's
What
smaller.
if there's a 7 at the end? Like like 0.666666667.
It's just rounding in your calculator.
Okay. So when I just put 0.67?
Well, no.
Times 2.
You need to do something to the top and something to the bottom that'll work.
You don't need to do that.
For both.
So take that times 2 and that times 2. What do you get? 1 times 2? 4 times 2? 1 times 2 is 2. 4 times 2 is... Divide both numbers by what? 5.
Does it need to be a decimal?
You come to decimals if you're checking your fractions.
Okay.
You're still gonna have a fraction as an answer.
Okay.
Guys, let's just talk about the first one right here. 10 over 15. I need to write an equivalent fraction to 10 over 15. So name me an operation I could do to the 10 and the 15. Both the same. All right, you're saying divide by 5. Mason, why are you saying divide both by 5?
Because there's 0 and a 5.
All right, he's saying, you know what, 10 and 15, I can divide both of those values by what value? 5. One's ending in 0, one's ending in 5. So if he says divide both of these by a 5, divide both the top and the bottom by 5, let's see what we get here. What is 10 divided by 5 up top?
2,
So his equivalent fraction is 2 over, what's 15 divided by 5 on the bottom?
3.
Okay, so he came up with a smaller fraction. I shouldn't say smaller, I should say he reduced his fraction. He came up with 2/3. Now how would I know if he's right? Well, isn't this the part where I can jump into the calculator and say, okay, let's see what 10 divided by 15 is first. When I go 10 divided by 15, what do I get as a solution? I get this bunch of 0.6's, right? 0.6 repeating?
Yeah.
So if 2/3 is an equivalent fraction, what should this equal when I divide that out? Should be same thing, right?
Yeah.
So I'm gonna go 2 divided by 3. And again, is that what I get?
Yes.
0.6 repeating. So are these equivalent?
Yep.
Yeah. Did anybody have values other than 10 and 15 that were larger than 10 and 15?
I had 3 over 5.
3 over 5.
That's, sorry, never mind.
Okay, let's check 3 over 5. Is that the same thing right here, John? Okay, so we know something's gotta be wrong, right?
Yes, I'm sorry that I
No,
said
that's
that.
alright, that's alright. I think if you use divide by 3, I agree 3 will go to 15, but does the 3 go into the 10 though? No. You know, honestly, one of the easiest things in the world to do is just double both of them. Let's try that. What if I doubled both of them? What if I had 10 over 15, and we said, let's just multiply both the top and the bottom by 2. Double 10 for me, what have you got?
You got 20 and 30. 20
And this kind of goes back to Chelsea's rule. When I've got zeros on the end, what could I just do with them at the end? Can I dump the zeros right here? If I wanted to reduce, I could, couldn't I? But would 20 over 30 be equivalent also?
Yes.
Okay, so I can reduce stuff or I can make stuff larger, doesn't matter, all right? Real quickly then, so 20 over 30 would work. Somebody give me an answer for 1/4. 1/4 is already reduced, so you have to go ahead and do what with the numerator?
Times it by 2.
You're saying double both of them. Okay, so what did you get?
2 eighths.
2 over 8, I agree. Could I have multiplied both of those values by 6? Could I have multiplied both values by 6? Yes, the idea being whatever I do to the top, I have to do the same exact thing to the bottom, all right? That would have worked. What if I would have multiplied both by 6? What would you have? 1/4 was multiplied by a form of 1 in 6 over 6. What would this be as an equivalent fraction? Anybody?
Help him out.
6 over 24.
6 over 24, yep. That could work also. All right, again, I'm getting a lot of different answers here, but understand they all are equivalent, right?
Yes.
All right, 9 over 27. Anybody go smaller with this? think smaller. Can 8 numbers divide evenly into 9 and 27? What's one of those, Seth? 9 goes into both of them. So you're saying divide both sides by 9?
Yep.
So both the numerator divided by 9 and the denominator divided by 9 gets me 1 over what here? 1/3. Okay. Would 3 have gone into both of them?
Yeah, but that takes the longer way. You get 3 over 9, so then you divide by 3 again.
Okay, so yeah, you said 9 over 27 could be reduced. I could divide by 3 and 3.
And then you gotta divide by 3 and 3 again.
You get 3 over 9 here, yeah. And if you divide by 3 again, that would take you back down to 1/3. Good. Anybody go larger with those?
3 over.
What'd you get?
I don't know if it's right, but I got 27 over 81.
27 over 81? Sounds like you multiplied both by 3. Yep, 27 over 81 would work. Great. Any others that we had that were different? Again, we can get a variety of different answers depending on what you as an individual choose to do to both numerator and denominator, right? Okay. Questions about making equivalent fractions, first of all. All right, quickly on the second page here, then. Here we go.
Second page?
Of your notes.
Okay, thanks.
Backside.
I know.
There we go. This is the part right here, gang, that's going to be most important to us. It says, writing a fraction in simplest form using prime factorization. Our job right here is to write 8 over 36 and what? What's it say? What's it say right there? Simplest form. Okay, simplest form means that we're making both the numerator and the denominator smaller values. So if I go back to my front page right here and read through simplest form, it says simplest form is a fraction when its numerator and its denominator are relatively prime. In other words, I can't factor any other numbers out of it other than 1. Okay, let me show you how 8 over 36 works. To write this in simplest form using prime factors, okay? By the way, my fraction is 8 over 36. Can you guys think of a number that would divide evenly into 8 and 36? Other than 1. Does 2 go into both of them?
Yeah.
It does. It turns out that 4 will actually go into both of them as well, right? How many times does 4 go into 8, gang? How many times will 4 go into 8? 2. How many times will 4 go into 36?
9.
Whoops, what happened there? Okay, I'm going to tell you right now, 8 over 36 in simplest form is going to be too nice. Let's use this idea of prime factorization. How do you use prime factorization to take a fraction, 8 over 36, and write that in simplest form? Well, it's quite easy. What you do is you separate your numerator and your denominator, 8 and 36, okay? We're going to make factor trees for both. All right, so help me with 8 first. 4 and 2. This is pretty nice because the 2 is already prime, so help me out with 4.
2
times
2 times 2. So it looks to me like the prime factorization for 8 is 2 times 2 times 2, right? Everybody agree?
Yeah.
Okay. So in our fraction, 8 over 36, guys, I'm going to write this over here. In our fraction, 8 over 36, this is the same as, how can I rewrite my 8 as a product of how many 2's? 2 times 2 times 2. So I have 8 over 36 is the original fraction. I'm going to go ahead and rewrite my 8 as 2 times 2 times 2. All right? That's just the prime factorization there, right? Now, we've got to do the same thing for 36. Keeping in mind, what's our end solution going to be? What's our final solution going to be? We already know it's going to be 2 nines, all right? Let's tie this together. How do I break 36 down? I know 36 is 9 times 4, isn't it? 9 will break into 3 and 3. Yes?
Yeah.
And 4 will break into
2 and 2.
2 and 2. Okay, so I'm done there. So the prime factorization for 36 is 2 times 2 times 3 times 3. All right, no problem. So what am I going to write in the denominator for the 36? 2 times 2 times 3 times 3. All right, this is the big idea then today. I've taken both the numerator and denominator, done the prime factorization for both. I want to simplify them or write this in simplest form. Okay. Right in simplest form, you're basically looking for groups that are the same again. But instead of circling them and keeping them this time, when we start simplifying fractions, we want to start canceling some stuff out. So guys, right here, don't you have a 2 common with a 2 right here?
Yes, yes, yes.
So when you're simplifying fractions, you're just going to cancel what's common. So you got 1, 2 common with 1, 2 in the bottom. That set is gone. Okay, go through again. I got another 2 up top here. Does that 2 cancel with any other 2's in the bottom?
Yes.
It does. So I'm going to cancel this 2 and this 2. Okay, now, I've got a third 2 up top. Does that third 2 cancel with anything in the bottom?
No.
No. I've got some 3's in the bottom. Do those 3's that remain down there cancel with anything up top?
No.
Yes.
You're always canceling one from the top and one from the bottom at a time, as long as they're common. Is there anything from top to bottom that's left that is common?
No.
What did you have left up top?
2.
2. That's this part, isn't it?
Yes.
Yeah.
What did you have left in the bottom?
3 times
3 times 3, right? Well, what's that 3 times 3 part going to form for you?
3. 9.
9. So what's your fraction in simplest form?
2 9.
2 ninths. Okay. I want to try an example where everything cancels out for you, okay?
Yeah.
And I want to talk about what happens there. So we're going to put one down here on your own.
It's cold.
Okay. So real quickly, let's pick one like 8 over 40. Okay. We're going to write this in simplest form. 8 over 40 in simplest form. Guys, do we already know what the prime factorization from 8 is on the very top?
Yeah.
What is the prime factorization for 8 going to be?
2 times 2 times 2.
Everybody agree? Okay, I'm going to just write the prime factorization for 40 down real quickly, all right? The prime factorization for 40 on the bottom is the following. It's 2 times 2 times 2 times 5. Okay? All right, this situation is kind of unique in the fact that if I'm using prime factorization to reduce my fractions right here, it turns out there's times when one of the parts, either the numerator or denominator, might completely cancel. And some of us might look out there and say, well, there's nothing left. And I agree with you, there's nothing left up there. However, since we're talking about multiplication, you need to understand something here. Guys, what's this 2 and 2 going to do to each other? How many pairs of 2's are going to cancel, actually?
3.
3 of them. Guys, is there anything really left up top there? If you ever cancel something out completely up top, we agree that 2 times 2 times 2 on top was 8, right?
Yes.
Would you agree that if I multiplied that by 1, it would still be equal to 8?
Yes.
Yeah.
So anytime you cancel everything out, what value is really left in one of those spots?
1.
A 1. You okay with that?
Yes. Yes.
So if
Yes.
you ever get rid of everything at the top, there's still a 1 left. So what's this going to reduce to then, gang? 1 over what? 1 over 5. And again, one thing I'd strongly encourage you guys to do is this. In your calculator, how do you know you're right? Well, if I go 8 divided by 40 here, that was the original problem, I get 0.2 as a decimal, right? So if 1/5 is equivalent in simplest form, 1 divided by 5 had better be what value again? Well, 0.2, right?
Yes.
Do they match? So if you ever get something up here to completely cancel out, done. You're going to be left with a 1 now, right? Okay. You guys want to try one?
Yeah.
All right. You guys try this one. Let's have you, ooh, this is a nice one. I won't be so mean. Yeah, maybe I will. Okay, go ahead and use your prime factorization to reduce 36 over 54. Okay, again, do your prime factorization, write your numerator as a product of primes, write your denominator as a product of primes, see what you can get to cancel out.
9 times 6 is 36.
Good catch there, John.
Thanks.
How long did it take you to figure out the ins and outs of this little deal?
This, Vimeo?
Yeah.
Not long.
You are a rocket scientist.
Not really. I did stay at Holiday Inn Express last night.
Huh?
I did stay at Holiday Inn Express last night.
Why did you stay in a Holiday Inn Express?
It's a joke.
Okay.
Haven't you seen those commercials, John?
Yeah.
No, but I did stay at a Holiday Inn Express last night.
Meaning I am smart. I'm not that smart.
Okay.
But I save money.
Okay. Come on, Lenny and I need it now.
Alright, so John kind of caught me here, but is my prime factorization okay now?
Yes.
You guys agree with my 36, 2 2s and 2 3s up top? Agree on the bottom, 2 times 3 times 3 times 3 is my 54.
Yeah.
Alright, well help me out. What canceled up here?
The two twos,
Pair of 2s are gone.
and then the sets of threes.
A 3 gone with a 3. 3 gone with a 3, so what's left?
So 2 thirds.
So what's 36 over 54 as a fraction in simplest form? You would tell me 2 thirds. How do you feel? You guys okay with this?
Yeah.
Okay. How many have 2 thirds? Just curious here. Looks pretty good. Again, we're really doing the same stuff today as we did in the last section. Instead of circling what's common, we're canceling what's common now, right? Keeping what's left. So 2 thirds, very good. All right, last example here then.
Those cancel, but those don't cancel because it's 2 and a 3. Different.
Last example I'll run through
Yes.
is example 3. It's a simplifying monomials using prime factorization. Guys, here's the deal. We have a fraction. I'm going to write this over here. We have a fraction that says 14x to the second times y divided by 35x to the third. Okay. You know, and a lot of times when you guys get into some of the tougher math down the road, you're going to start seeing expressions a lot like this, and this should be second nature to you when you see it. But for now, our job today is to say, hey, I'd like to simplify this fraction right here. Now again, it's not just numbers over numbers. We got monomial over another monomial, right? Our job is still the same. We've got to do prime factorization for both sets. So let's do this. I need to break the 14 down up here in this first set, guys. What's that 14 going to break down into? Well, a set of primes, or a value for primes. What times what forms 14?
7 and 2.
Are 7 and 2 both primed?
Yes.
So to write the numerator as a product of primes, I'm going to call this 2 times 7 times how many x's here, gang?
2.
The x squared would be 2 x's, and then how many y's would I put up here for the prime factorization there? Well, there would just be
the 1.
1. So you guys agree with the way the top is written there?
Over.
How are you going to write the bottom now? 35x to the third. What's going to form 35 as a product of primes?
5 and 7.
5 times 7, good. And then how many x's you want down there?
3.
All agree with my prime factorization for the numerator and denominator?
Yep.
Yes.
Okay, it's not an idea of saying, no, we're circling what's common. We're going to cancel what's common to simplify this now. So in the numerator and denominator, tell me what my numbers or variables are that are common.
7 and 7.
7 and 7.
X and X.
X and X. Boom, boom.
And then that leaves you with 2.
Got another couple of pair of X's that could go, couldn't they? Everybody agree there?
Yes.
Let's see, the stuff that I haven't gotten rid of yet. What's left up top?
2y.
So my simplest form of this fraction would be 2y over.
5x.
Gosh dang, guys, that's good. this fraction in simplest form, one monomial over another monomial, is equivalently to y over 5x. Okay, now I think I'm going to have you guys try another one of those, but I'm going to say, yeah, I think that makes sense.
I do.
Okay, let's try one here. Let me know that you've got this down before I go to a new page. Everybody good?
Yeah, I'm good.
How about this side? Everybody okay? Everybody got that down?
Wait, what about the third box?
We won't worry about it today, John. It's okay.
What?
We're okay.
Okay.
Sometimes I put an extra box in there if I think kids don't have it, but I think you have it down, so we're not going to do another one.
It's the ghost flags.
Okay, let's try it. You guys try this one. Let's go 35,
Yeah, 35.
x to the second, y to the third,
Wait, do we need
times
to write
z,
this?
all over, let's go 42x,
Yeah, we don't need to write that.
y, z to the second. Okay, so I want you to try and simplify that fraction right there. Put it in simplest form using prime factorization. Take a couple minutes. Get stuck, let one of us know, but always compare, all right?
That's a Z.
That's a
But I
Z.
have a line through it.
Put a little line through it so some people will think it's a 2.
One. X, Y, Z.
You know your ABCs. Do we have advisory today, Dave?
Yes.
I think so.
I don't know. We do?
Take it all the way down. So you know you got 6 times 7, right? So you
Yeah.
break your 6 up into 2
You know what we're doing?
No.
What grade level do you have?
Sophomores.
Okay, because Amy sent something out, sophomores, please share a night talks information for next advisory. The flyer was put in your mailbox last week, it says.
Well, look
You
here.
have to let
You just a
parent
little
control
all over the
too.
place with your
GPA,
Okay.
class rank.
You got everything. So you cross off what's common. Okay? It's hard to read this stuff. 7s are common. X's are common. Is that an X? Okay. This is a Y and a Y.
I think the main thing is
This is one of these
I need
Z's,
to.
meeting.
right? So you come over here, what do you have left? I'm trying to decipher this. 5.
You know what, come on, do this one?
Not so.
Right? And then what else do
Come
I
on,
got?
guys. Don't be
I
shy.
got a Y here.
Lily, help me break the first one down. What'd you have?
X and Y, but you're missing a Y here, because we had
I
Yeah,
have 7
there's a
times
Y.
5 times 7.
Ys.
How many X's?
2. X,
1, 2,
1 Y.
How many Y's?
3.
And a Z, right?
Yeah, you're missing 30. Yeah, well, there's 3 of them, yeah.
Everybody agree with my top?
Okay. There's 2
What
left.
about the bottom? Anybody on the bottom?
Is there an X, yeah?
How'd you break 42
We got a
down?
bottom.
Brandon, how'd you break 42 down?
2
Look
times
at the
3
door for
times
him,
7
Chelsea.
times X times Y.
Say that, hold on, one more time.
2 times 3 times 7.
2 times 3 times 7. Okay. And then what?
Times X
Times an X times a.
times Z times Z.
There we go.
Alright. Guys agree with prime factorization first of all?
Yes.
Alright. So I'm looking for what's common to cancel. Help me out.
The 2 X's and the 7s.
2 times 3 times
7s
7.
are gone.
Okay,
This X is gone.
And you missed some stuff here. Okay.
Okay, what else?
The 1 Y.
One y from each set is gone.
And one z from each set.
And one z from each set is gone.
Yeah.
Okay, so let's talk about what remains in the numerator. What's that going to look like as an expression?
You take 3 times, no, 5 times 3.
That'll be 5 times x times
Y.
y to what power here?
Second.
You guys agree with my numerator? 5xy squared. How about the bottom? What's left in the bottom? I could multiply the 2 times the 3, couldn't I?
Yes.
Which is what?
6.
6z. There it is. How many had that?
Next one.
How many want to try another one?
No.
Do we need to try another one?
No. 6Z.
Again, it's just a matter of writing everything out and looking for what cancels, right?
Yes.
Do you understand why I'm putting stuff back together right here, like the 2 and the 3 and the 6 part down here? Okay, and then likewise, the y times the y is my part up in the numerator of y squared. Good there? Okay. Do you guys have stuff down there then?
Yes.
All right. Well,